In this problem, we're being asked to identify the graph of the solution set given here. So we're graphing a linear inequality in two variables. Now, one of the things I want you to note is as we look at the four multiple choice options, I want you to notice that all the lines are in the exact same place. So we don't really need to worry about the whole slope and y-intercept and where to graph this thing at. As we look at the four multiple choice options here, what's really jumping out at me is that half of them are dotted and half are solid. Half are shaded above the line and half are shaded below the line. So those are really the two things that we wanted to look at and to differentiate is whether it should be dotted or solid and which direction it should be shaded. So let's do some review for those topics. So first of all, let's talk about dotted versus solid. So remember, if we have less than or equal to, or if we have greater than or equal to, if we have an or equal to in our inequality, then remember that that means do the same thing as if it was just equal to. In terms of graphing a line, that's when we graph a solid line. If we are plotting a point on the number line, we would plot it as a closed circle. If we are giving interval notation, we would use brackets. So that's what the or equal to is going to mean. Now, if we don't have or equal to, so if we have just less than, or if we have just greater than, that's when we do something different to say this point isn't included. We use a dotted line in terms of a line. We use an open circle if we're putting something on the number line. And in interval notation, we use parentheses. So remember, what this is doing here is this is giving us the border between the points that work and the points that don't work. So where you're equal is where you're going to change from being less than to being greater than, or vice versa. So that's what's going on with determining whether it's solid or dotted. So in terms of our problem here, we notice that we do have an or equal to, so we should be solid. So we're going to cross off A and D. So the difference between B and C here is just what's shaded, the top stuff or the bottom stuff. Now, I wanted to avoid going with rules. I don't want a rule that says every time you see less than, shade this direction. Those rules require us to solve for y to get the y by itself, which also include rules like dividing by a negative means flipping the inequality sign. What I do instead, what we've done throughout this entire semester so far, is to say, well, either the entire top is shaded or the entire bottom is shaded. So let's just pick a point in one or the other and see if that point should be shaded or not. Does it satisfy the inequality? And everybody's favorite point, the easiest point to test, should be the ordered pair 0, 0. And remember, we can always test 0, 0 unless 0, 0 is on the line, because that's not going to help us then. If 0, 0 is actually on the line, that doesn't tell us one side or the other. And that's what we're looking for, is we're looking for a point that's on one side or the other. So in C, the origin is shaded. In B, the origin is not shaded, so it's up to us to determine should it be. So we plug 0 in for x, we plug 0 in for y, and we want to determine if this is a true statement or a false statement. So we find 0 is less than 4 is definitely a true statement. The fact that this is true tells us the ordered pair 0, 0 should be shaded because it's true. So the option that has it shaded is C, because it's true. It made the inequality true when we plugged 0, 0 in. That gives us C as a correct answer.